page 5, number 1. And remember that we learned to balance a couple set days ago in the notes. Pardon me. Apologize for that. Okay, so we learned in the notes that we're going to balance by using polyatomics first, all other elements that aren't hydrogen and oxygen, and then hydrogen second to last, oxygen dead last. So that's the order that's recommended to make the most success for balancing. All right. So I'm going to get rid of that. That was in the notes the other day. Now we're going to look and we're going to see that, in fact, we do have a polyatomic. NO3 is on both sides of the arrow. NO3 is on both sides of the arrow. It's a poly. It has to be on both sides treated as a unit. So we're going to list it as a unit instead of individual atoms. This is what the shortcut is for this. This allows us to make this a lot faster. Then I still have Cu and I have Ag. You have to account for all the pieces. Now I'm going to scratch some stuff out up here. Don't scratch out what I'm scratching out. Just kind of watch for a moment. So I have accounted for NO3, right? I accounted for the Cu and I accounted for Ag. Everybody see that? Okay? So that's what you want to think about when you're doing this. Let me get my marker back to something that you can read. Okay, perfect. So we have one NO3, we have one Cu and one Ag on the left, two NO3s, one Cu, one Ag on the right. Questions about my list or the numbers? Okay, so we're going to get we're going to start with our NO3. That's why we put it first in our list, right? And we're going to get two NO3s. We can only put numbers in front. I can't put numbers in between or after. It won't count if it's after. So I put a 2 here, which remember there's really a 1 here with Ag and there's really a parentheses 1 there. So now I've got 2 nitrates, but I also impacted silver, so I got to fix it. I got 2 silvers. Okay, so I'm not going to worry about silver unless I need to. I like to keep going down my list. Okay, now that's not the only way you can do it, but you'll see me model that the most of the time. The copper looks good. It's 1 to 1. But silver is not balanced, so I need to put a 2 on the right where silver is, which allows silver to go to 2 because there's a 1 there. Questions about that? I would read this to you as 1, 2, 1, 2, but you do not write the 1s. We read it, but we don't write 1s. And we read it so that you're following the placeholders. Questions about number 1? Okay, we're skipping 2 for today. We'll do it tomorrow. We're going on to 3. On 3, I see polyatomics. I have an SO4 group and an SO4 group. So I'm going to treat that as a unit. And then I'm going to put Al and Br and hydrogen, because that's what's left that isn't part of the polyatomic. And notice I put hydrogen last, even though it's first in the list, let me say it properly. It's first as we look left to right, but I want to put it last because usually hydrogen is the difficult beast of everything and oxygen is even worse. Okay, we'll kind of see that tomorrow. So we have 1 sulfate, we have 1 aluminum, 3 bromines, and 3 hydrogens. Oops, that's 2 hydrogens, apologize, 2 hydrogens, I don't know what I was looking at. And then over on the left, let me try that again. On the left, we had 1 sulfate, 1 aluminum, 3 bromines, and 2 hydrogens. On the right, we have 3 sulfates, 2 aluminums, 1 bromine, and 1 hydrogen. So first, questions about the list. Second, questions about the numbers. Anybody have any questions about any of that so far? Okay, so then we're going to balance our sulfates first by putting a 3 here. When I put that 3 here, it changes this because remember there's really that there, right? So 3 times 1 is 3. But it also changes my hydrogens to a 6 because 3 times 2 for hydrogen on the left is 6. But I'm going to leave it alone. Just leave it down there for now. I'm going to go take care of aluminum next. So I need 2 aluminum, so I'm going to put a 2 here, which makes aluminum go to 2 and bromine go to 6. Okay, and so aluminums look good, bromines do not. I have 6 and 1, so I got to put a 6 in front. Okay, apologize, I was trying to figure out what that was. That was from last week. So 6 in front here, so that makes my Br go to 6 because remember there's a 1 and a 1 there. But it also makes my hydrogen go to 6, and now we're balanced. With a 3, 2, 6, 1, 3, 2, 6, 1, we're balanced. Questions about number 3? Okay, let's look at number 4. There's something about number 4, and that's why I'm doing it with you, that is whenever you have water on one side, the left or the right, and the other side has OH, hydroxide, it'll probably be fastest and most helpful if you write water instead of H2O as HOH. So if you have OH on one side and H2O on the other, where you see the H2O, I highly encourage you to write it as HOH. All right, so then we have OH and we have PO4, so we have 2 polyatomics, right? We have PO4 and OH on both sides. Then we have Al, and then we have H. Questions about my list? Okay, so I have 3 OHs on the left. I have 1 PO4, 1 Al, and 3 H's on the left. On the right, I have 1 OH, right? Because this is really HOH. So I have 1 OH, 1 PO4, 1 Al, and then I have 1 H that's not part of the OH we already counted for up here. Questions about my list and my numbers? Okay, so we're going to fix hydroxide first, OH first, by putting a 3 on the right. When I do that, that makes OH go to 3. It also makes hydrogen go to 3, because remember, this is really, even though we don't write it, this is really what HOH is. It's H1 and OH parentheses 1, isn't it? Because OH is poly. And notice it's balanced with a 1, 1, 1, 3. Questions about number 4? Okay, can you go try number 8, please? You try number 8 on your own, and I'll go over it with you in just a few minutes. Try number 8 without me. Okay, so number 8 then, let's go over number 8. We can do NO3 as a group because it's a polyatomic on both sides. Remember, this is just a shortcut method, the NO3 being polyatomic. Sometimes, even if the polyatomics on both sides of the arrow, it still won't help us balance. Sometimes we still have to go back to default, which is individual atoms. So I have, pardon me, NO3, Al, and PB. I have 2 NO3s, 1 Al, 1 PB. 3 NO3s, 1 Al, 1 PB. So, excuse me, nitrate has 2 and 3. So I could get into 2 and 3, I got to get both to a 6. So I'm going to put a 3 on the left in front of where the nitrate group is, but it impacts 2 things. It makes, yes, it makes nitrate go to 6. 3 times 2 is 6. But it makes lead also go to 3 because there's a 3 there that impacts the lead too. So to get 6 nitrates on the right, I'm going to put a 2 in front, which makes, yes, my nitrates go to 6. 2 times 3 is 6. But it also makes my aluminums go to 2 because the 2 impacts aluminum when it's in front of it. So nitrates look good. Now we need to fix aluminums. To fix them, I'm going to put a 2 over here. It only impacts the aluminum. Okay, and I'm going to, now that's fixed. To fix the lead on the right, I'm going to put a 3 in front because that 3 only impacts a lead because there's a plus sign blocking it. So now we have a 6, 6, 2, 2, 3, 3, and it is balanced. Questions about number 8? Okay, let's go back and look at number 5. Any questions about 8? I did that a little fast. Okay, go back to number 5. If you have a question about 8, we can go back to it in a sec. Okay, number 5 does have a polyatomic of NH4 here, but there's no NH4 group on this side. So then I can't use the polyatomic shortcut. I need to use individual atoms. So we have nitrogen, chlorine, and hydrogen. I did this problem specifically in this order for this reason, because I wanted you to see that we have 1 nitrogen, 1 chlorine, but we have 4 hydrogens because there's 3 here and 1 here. So on that side, there's already 4 hydrogens. Even though if they're on the same side, you can add them, is what you would do. Okay. On the other side, we have 1 nitrogen, 1 chlorine, and 4 hydrogens. So this is already balanced. So you just need to tell me that it's already balanced if something is already balanced. Questions about 5? Okay, I'd like you to go try 13, please. You go try 13, and we'll go over it in just a moment. So we're looking for polyatomics. We see a polyatomic here, SO4 and SO4, so we're going to treat it as a unit. We have aluminums, chlorines, and hydrogens. We're going to leave hydrogen dead last. We have 1 SO4, 1 Al, 3 Cls, and 2 hydrogens. We have 3 SO4s on the right, 2 Als on the right, 1 chlorine, 1 hydrogen. So we got 2 and 3 in not 2 and 3, apologize, 1 and 3, so I got to get them both to 3. So on the left-hand side, I'm going to put a 3 in front, which impacts the sulfate. 3 times 1 group of SO4 is 3. But it also impacts hydrogen, makes hydrogen go to 6. Aluminum is 1 and 2, so I'm going to put a 2 over here, which impacts aluminum to a 6, but it also makes aluminum to a 2. Aluminum goes to a 2. Chlorine goes to the 6. And then to fix chlorine, I have to put a 6 here, which makes chlorine go to 6 because 6 times 1 is 6, and hydrogen go to 6 because 6 times 1 is 6. So it'd be a 2, 3, 1, 6 for balancing.